Okay, so let us move on to the next section, which contains multiple correct type questions. Question number 50 says that let in be the integral from 1 to e ln x raised to power n dx, obviously where n is a natural number, then which of the following is or are correct? So students, we know that this is a standard format of reduction formula and we'll use by parts in this particular question to solve it. Okay, so let us start with by parts. In is integral 1 to e ln x raised to the power n dx. So 1 into this. So 1 is the first function, ln x raised to power n is the second function. Integration of first function x, second function as it is, from 1 to e, minus integral of the first function, differentiation of the second function, n into ln x raised to power n minus 1 into 1 by x dx. And the integral is from 1 to e again. So this is, if you put x equals e, I will get e. And if you put x equals 1, you will get 0. So e minus 0 minus n times ln x raised to the power n minus 1 from 1 to e. So that means it is I of n minus 1. So in comes out to be equal to e minus n in minus 1. So this is the reduction formula ultimately. Okay. For using this reduction formula, I need the value of I1 separately. So I can easily calculate I1. I1 will be integration 1 to e ln x raised to power 1 dx. So it is x ln x minus 1 from 1 to e. That will give you 0 for the first part and minus 1 for the second part. So 1. I1 is equal to 1. By using this particular formula, we can calculate I2, I3, I4 and so on. So I2 will be equal to e minus 2I1. So e minus 2. So I3 will be e minus 3I2. So that will be 6 minus 2e. Similarly, I4 will be e minus 4I3. So that will be 9e minus 24. Ultimately, I5 will be e minus 5I4. So 120 minus 44e. So all the data is with us: I1, I2, I3, I4 and I5. I2 plus I4. So I2 plus I4 will be 10e minus 26. Correct. I3 plus I5 will be 126 minus 46e. Correct. I1 plus I2. So I1 plus I2 will be e minus 1. Again correct. I4 is 9e plus 24. I4 is 9e minus 24. So this option is wrong. Final answer, that is ABC as the correct option. So once you deduce the reduction formula, you just have to put the values of n over there and choose the correct options. Okay. Let us move on to question number 51. Question number 51 says that consider a function fx given as the integral of sin inverse x to cos inverse x, sin cube t cos t dt. Which of the following is our correct? So in order to solve this particular integral, I will directly put sin cube t as p. So cos t dt will be dp and the integral will be p cube dp. So that will be p power 4. So it is simply sin t power 4 upon 4 from the limits sin inverse x to cos inverse x. If you put cos inverse x, that will be sine of sin inverse root under 1 minus x square whole raised to power 4 minus x raised to the power 4 upon 4. So that will be 1 minus x square whole square under root raised to power 4 is whole square minus x raised to power 4 upon 4. So this will give you minus 2x square plus 1 by 4. So fx is simply a quadratic polynomial. The curve y equal to fx passes through point 0, 0. Wrong. Curve y equal to fx has a point of local minima. This can never have a point of local minima because the leading coefficient is negative. It will have a point of local maxima. Wrong. Minus 1 to 1 fx dx is equal to 1 by 6. So you can easily integrate it and the answer will be 1 by 6 only. Option number C is correct. Maximum value of fx is 1 by 4. So maximum value definitely equal to 1 by 4 because it is 1 by 4 minus x square by 2. So D is also correct. Final answer CD. Let us move on to 52. Question number 52 says that consider a real valued 1, 1 function fx whose domain and range are R and R respectively. Another function gx satisfies the differential equation g dash x into fx is equal to f dash x times 2fx minus gx, where f0 is 1 and g0 is 2. We have to comment about 1, 1 on 2 or some solutions. We have to comment about gx in the given options. Okay, so let us try and solve this differential equation. G dash x into fx is equal to f dash x into 2fx minus gx. Taking this term to the left hand side, I have g dash x fx plus f dash x gx is equal to 2fx into f dash x. This is gx into fx whole dash is equal to 2fx into f dash x. With respect to dx on both sides, so we will get fx into gx is equal to f square x plus c. Because this will be, if you put fx as t, f dash x dx will be dt. So this will be the integral of 2t. So we have gx as fx plus c upon fx. We are given that at x equals 0, f0 is 1 and g0 is 2. So 2 is equal to 1 plus c, c comes out to be 1. So from here I can say that gx is fx plus 1 by fx. Now students, this is the final function we are looking for. So now the real analysis starts. Okay, first of all, fx is given to be a 1, 1 function. So now we have to choose the correct options. Now the real analysis of this particular part starts. It is given that fx is a 1, 1 function. Based on this, we have to comment whether gx is 1, 1 or not. Now students, there will be exactly one value of x for which fx is equal to 2. At that particular point, gx will be 2 plus 1 by 2. But there will be one more value of x when fx is equal to 1 by 2 say. On that particular value of x, gx will again be 1 by 2 plus 2, that means 5 by 2. So gx is taking value 5 by 2 at two distinct points. Okay, so that means gx is not a 1, 1 function, it is a mini 1 function. So it is going to happen for every particular value. Okay, now commenting upon the range of gx, gx can be visualized as a number f of alpha plus 1 by f of alpha. So number added to its reciprocal is either greater than or equal to 2 or less than or equal to minus 2 based on AMGM inequality. So that means the range of gx is not all the real numbers. Okay, it is minus infinity to minus 2 union 2 to infinity. Talking about d part, again it is wrong. Gx is equal to 1 can never have any solution. So only correct option is option number B. Okay, so it is a very smart question based on some analytical understanding of the functions. Okay, let us move forward to question number 53. Question number 53 says that through a point P, alpha, comma, beta, comma, gamma, a plane is drawn at right angles to OP to meet the coordinate axes in A, B and C respectively. A, B and C. If OP is equal to R, then what is the area of triangle ABC? So we have a plane passing through a particular point P, alpha, comma, beta, comma, gamma. And this particular plane is at right angles to OP, where O is the origin. So let us have O, 0, 0, 0. Obviously, if the plane is right angles to OP, this is my normal vector. And if I have the normal vector with me, direction ratios are alpha, beta, gamma, obviously. The equation of plane can be easily written because I know one point on the plane, that is P itself. So direction ratios alpha, beta, gamma. So alpha into x minus alpha plus beta into y minus beta plus gamma into z minus gamma equals 0. If we take a general point over here, R point as x comma y comma z, so rp dot n vector is equal to 0. This is the result and the equation of plane. So alpha x plus beta y plus gamma z minus alpha square minus beta square minus gamma square equals 0. That means alpha x plus beta y plus gamma z is equals to r square. Now students, this particular plane will cut the coordinate axis, that is the x-axis, in the point r square by alpha comma 0 comma 0. y-axis in B, so let it be, so it will be 0 comma r square by beta comma 0, and C point will be 0 comma 0 comma r square by gamma. So we have the area of triangle ABC as 1 by 2 magnitude of AB vector cross AC vector. Because it is 1 by 2 AB sin C or BC sin A or AC sin B. So this is directly the geometrical application of cross product of two vectors. Okay. So let us write down the expression AB vector cross AC vector. So area will be 1 by 2 the magnitude of AB vector. So B vector minus A vector, I cap, J cap, K cap, AB vector. So minus R square upon alpha, R square upon beta, 0, AC vector. Minus R square upon alpha, 0, R square upon gamma. So this will be 1 by 2 into the magnitude of R power 4 upon beta gamma, I cap, plus R power 4 upon alpha gamma, J cap, plus R power 4 upon alpha beta, K cap. So we have to take the magnitude of this vector. So 1 by 2 R power 4 under root of 1 by beta square gamma square plus 1 by alpha square gamma square plus 1 by alpha square beta square. So this will be 1 by 2 R power 4 upon alpha beta gamma with a magnitude sign, root of alpha square plus beta square plus gamma square. That is R power 5 upon 2 times magnitude of alpha beta gamma. So we have this as the final answer. Let us see the options. Option number D is the correct choice. Okay, so there is only one option which is correct, that is option number D. Okay, let us move on to 54. So question number 54 says that 3 points are selected from the intersection points of two concentric circles with two equilateral triangles as shown in the figure. Then the probability that these 3 points are the vertices of a triangle, the probability that these 3 points are collinear. So there are two possible cases that we have to explore. So first of all, let us calculate the probability that these points are collinear. If it is small p, 1 minus p will be the other probability. Okay. Probability that the 3 points selected are collinear. So 1 line, 2 line, 3 lines, 4, 5 and 6. Out of these 6 lines, select any one line. Then each of the lines has 4 points. So select any 3 points out of those 4 points. That will be n of e, the numerator. N of s will be the total number of points, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12c3 directly. So that will be, this is for collinear, 6 into 4 divided by 12 into 11 into 10 divided by 6. That is 6 upon 55. So that means option number B is correct for collinear. 1 minus 6 upon 55, that is 49 by 55. The only other possibility is that if the points are not collinear, they will form vertices of a triangle. Very simple. So option number A is also correct. Final answer, rest has option number A and option number B. Let us move on to question number 55. Question number 55. It says that consider a function fx as box sine cube x minus box sine square x plus box sine x, where x belongs to open interval 0 to 2 pi, where the box represents the greatest integer function. Then the number of integral values they are asking you, and they are asking you the minimum and the maximum value of fx. So let us have the coordinate axis over here. We will draw the graph of y equal to sine x, mark various intervals in it, and will decide the corresponding values of fx according to that. So this is y equal to sine x. Over here in the next x-axis I'll draw y equal to fx. So this value is pi by 2. This is pi. This is 3 pi by 2. And this is 2 pi. So students, find the value of fx in each of the intervals 0 to pi by 2, pi by 2 to pi. I'll find the value of fx in each of the quadrants. 4 quadrants are mentioned, first, second, third, fourth, and at different points, that is pi by 2, pi and 3 pi by 2. When I'm talking about the first quadrant, sin x is positive, sin square x is always positive, sin cube x is positive. Values lie between 0 and 1. So greatest integer of sin cube x 0, this is 0, this is 0. So this is 0. Open interval, 0. At x equals pi by 2. First term is 1, second is 1, third is 1. So the value is 1. So this value is 1. Second interval. Again, the values decrease from 1 to 0. First part is 0, second is 0, third is 0. Again 0. At x equals pi. At x equals pi, again it is 0 minus 0 plus 0. So this is 0. So we'll put a closed circle here. Now when we go to the third quadrant, greatest integer of sin cube x as well as sin x become minus 1, and the greatest integer of sin square x becomes 0 again because it is a positive quantity still. So minus 1, minus 0, minus 1. So minus 2 till this particular value minus 2. At x equals minus 3 pi by 2. Minus 1 for the first term, minus of 1 for the second term, minus 1 for the third term. So minus 3 is the value. We'll have to elongate this line. Minus 3 at 3 pi by 2. Now when I talk about the fourth quadrant, again greatest integer of sin square x goes 0. The remaining values are behaving the same as they behaved in the third quadrant. So the values will be minus 1, minus 0, minus 1. So minus 2. 2 pi is not under consideration, as 0 is also not under consideration. Range. 4 distinct integers. Minus 3, minus 2, 0, 1. Minimum value minus 3, maximum value 1. Option number B and C are the correct answers for this question. Okay. So whenever you are encountering such a problem of greatest integer function involving trigonometry, should always move quadrant by quadrant and very carefully decide their value at the right angles, that is pi by 2, double of right angle, triple of right angle, and so on. Okay. So let us move on to the next section, which contains matrix type problems.